Yeah.
Physicists in Egypt have published research on the theory of rainbow gravity. Now, it suggests that gravity affects coloured light differently. Are you lost? Well, to explain all of this, we're joined by the man of the rainbow shirt himself, Dr. Karl. Dr. Karl, as
Good morning.
Andrew kindly just pointed out in the break, we're too thick to even understand the question. So can you just take it away?
Okay, so I'll give you 4 things as an intro and then hit you with confusion, and then out of that we'll come to the light.
Sounds good.
Number 1, the Big Bang. So these are the 4 bits of background you have to know. So the Big Bang theory basically says that everything was sort of gathered together with infinite density in one spot, and then something happened and all started spreading out. We've got various data, and there's various reasons why we believe in the Big Bang theory. That's number 1. You happy with the Big Bang theory? Okay. Second thing is causality. Now, suppose I'm holding a pen in my hand, and then that pen will not do anything unless I push it. So that's causality. You're familiar with causality. Things happen only if you make them happen.
Yes.
Right? And similar, so that's number 2, causality. Number 3, space-time. That's what we're looking at now. This is space-time, right? So we have this fabric of space-time.
Right.
So what are we looking at here?
This is the moon going around the Earth, and you think, well, it's sucked in by gravity, but let's go a little bit deeper. Here we're going ahead of ourselves. This is the rainbow theory. Go back to that sort of gritty, fabric-y thing. Which we'll get to in just a minute. But anyway, so the fabric of space-time, here it is. So we have 3 dimensions of space, which are backwards, forwards,
yes,
left, right, and up, down.
Yep.
Yes.
And the 4th dimension is time, which ticks away at 1 second per second. Okay, so this is the flat fabric of space-time, which is all around us in the universe.
Yep.
And then, see over here, we have objects like the moon and the sun, and
yes,
they cause dents. And then they cause dents in the fabric of space-time, and everything goes around and follows this fabric of space-time.
So
whether it's light or matter or
these
a
get
comet.
sucked into the dent.
They get sucked into the dent. They're
Yes.
going to go in a straight line, and then they follow a curve. So we've gone through Big Bang, causality, how space-time is normally flat, but objects cause a dent, and everything, notice the word everything, will follow the same curve through it. So that's gravity. Now we're going to hit you with a contradiction.
Come on.
I'm sorry.
Come on, baby.
This is just the background. Okay,
Right.
You've heard of relativity and quantum mechanics. Relativity says, the basis of relativity is that we have causality. If you do A, B happens.
Yes.
But space-time is wibbly-wobbly stretchy. Quantum mechanics, which is also working, says the exact opposite. There is no causality. B can happen without A, but the fabric of space-time is fixed. So we've got quantum mechanics and relativity, which are both working, and they're both built on completely contradictory assumptions.
Right.
Now we get to the rainbow theory. This is a way out of the fact that we've got
That
2
we've got
ways
2
of
things
that are contradictory.
Operating contradictorily.
Which work. And then what the rainbow theory says that, okay, you've got the space-time fabric, and maybe it affects different things differently. Maybe it affects different energies of life differently, thus giving different energies. So something comes in and follows the curvature of space, and depending on whether it's high energy or low energy, will behave differently. And what does this lead to? It leads to the fact that there might not have been a Big Bang. Because, so if you follow through the mathematics, you end up with a universe that way back, go back through time, was not infinite in density.
Yes.
And therefore,
Yes.
there might not have been a Big Bang. And this leads us to the final follow-up, which is the big finish. I hold my theories on the tips of my fingers so the merest breath of fact will blow them away. So for the non-singular rainbow universe, we have no proof. We might get it in the next series of space telescopes, and in that case, everything we've believed about the Big Bang theory could be just blown away because we've got more evidence. That's how science works. Go, show me the facts. At the moment, they're playing around with pen and paper. There was a famous physicist who once gave a Nobel Prize, a Nobel Physics Prize speech, and he said, if I have neglected, he was an experimentalist, if I have neglected to thank any theoreticians, it's not because I have forgotten to do so, but because I hate them. Because it takes me 10 years to do an experiment, and these theoreticians, they come up with a theory every time they have a cup of coffee.
Sure.
The rat bags.
Karl, I'm exhausted.
You should
The
be.
pictures were pretty. Didn't understand a word you
Oh, you
just said,
understood a
but
bit
thanks
of
for
it.
going to so much trouble.
Funnily enough, the High Court and the Canberra Parliament have been debating this issue all
They
week.
have
We have
been.
quantum
The Big
mechanics.
Bang theory or the rainbow theory.
Yeah, we have non-causality
Thank you,
in
Dr.
Australian
Karl.
law. Thank you.
Thanks for coming.